Today's a very special day, very special video. It's your day today, Yuri. Today's our video. One of the things in it is index fossils. You're famous, Yuri. You're an index fossil. So index fossils, probably one of the most important things with putting events in order, shows up on the test all the time. We got a super special rhyme and flow. Yuri even color coded it. In a sedimentary rock bed, index fossils are short-lived and widespread. So remember, red is a vocab term, blue is the things that need to be in your brain, blue for brain. I forgot to do that with like the first 16 videos, so obviously my brain is a little blue right now. Where is it? Volcanic ash deposits and meteorite deposits. All three of these things are called time markers. Did I make like a fancy thing up there? Time markers, hugely important concept. Index fossil is the most important, especially our famous Yuri. He's the New York State fossil, by the way. So he's famous. I mean, he was very short-lived and he was widespread. Lived all over the place when New York was covered in that shallow, warm sea. I mean, you're still alive. Don't tell him he's a fossil. So, short-lived and widespread. We use index fossils. We'll do a few questions to match up which fossils were only around for a little bit of time. Now, all of that stuff with page 8 and 9, separate ESRT video that one day I'll have a little link for up here that goes to just how do you find those fossils and get that information off the reference table. For right now, we're just going to stick with putting events in order and matching the rocks up, okay? And there's some different principles of geology or like the laws of geology. So the first one is superposition. Superposition is, we use pancakes to relate that, putting things in order. Oldest on the bottom, youngest on top. So if we look at this picture of the Grand Canyon, you can see that those layers of rocks, there's different formations and the oldest one's on the bottom. Okay, so the next one that goes with that superposition is original horizontality. So sedimentary rocks all start out in layers. Let's look at a picture that shows, sedimentary rocks are sediments that are deposited in the ocean, and they just start out as those big flat layers that are continuous. Okay, so you can see that like those layers are continuous all the way across, but eventually they start to get eroded and stuff, and those layers get broken apart, or you don't see the entire sequence. And so then you can match up those layers to figure out which ones used to be connected. And if you're looking for things like oil deposits, you can find one layer and another layer and match them up and get that oil. Cross-cutting relations. So all rocks start out as those nice flat layers, and if something goes through it, you know that it must have been a newer event. So let's look at a picture that shows that. Okay, so in that picture you can see, let me just look at this picture here to make sure I'm talking about something right. So that magma that came up and out of the volcano, that's called a dike that goes right through. That igneous rock must have came through after all of those sedimentary rocks because it cuts through. So we'll do some questions with different faults. Anything that does some cutting is younger or newer. And then the last one, unconformities. There's different kinds of unconformities. Shows up quite a bit. It's that squiggly line. It's a buried erosional surface. So that's another event in the order of putting these things from oldest to youngest. So we'll do some of those questions, put things in order. That's the skill, the main skill that you have to do. It usually shows up a few different times on the test. And I'm sure I forgot something, so you'll see me after the video again when I say what I forgot. Okay, so we have three different outcrops of rocks, and there's going to be a lot of different possible things that show up. But one of the things you have to do is put them in order and match up which layers go with which. So, oldest are on the bottom, but these are three separate outcrops. You can use index fossils to try to match up, but it doesn't look like we have any that are a match. So I start to look for similar rocks. I see green shale with an unconformity and then white limestone. and then red sandstone. Well, I see green shale, gray sandstone, white limestone. Red sandstone, oh, green shale, white limestone, red sandstone. So we've got that green shale with the white limestone underneath it. There's an unconformity that's missing rocks. That's probably this gray sandstone right here. So that gray sandstone probably fits right there. And what I'm doing here is I'm starting to try to connect some of the rocks. So now I've got, it starts to kind of click. The tan conglomerate matches up. The brown siltstone matches up. And you can see those layers of rocks are now starting to come in order. I'm matching them up. White limestone, this was some white limestone. So now I know that that brown sandstone is older than all these rocks. And if I match them up, the brown sandstone would have been down here somewhere. So that could be my oldest. But then I start to see, like, I've got my green shale over here. And I've got my gray sandstone that is probably still missing. And then I've got my white limestone that matches up there. Red sandstone, gray siltstone, brown sandstone. Red sandstone, gray siltstone, brown sandstone. It looks like these two are going to be the absolute oldest rock. And then so if I match all this up, my youngest rocks look like it's probably the red conglomerate. And that's how I correlate. I put those things in order. So now, based on the evidence shown in the diagram, which layer is older than the fault? Older than fault XY, it's got to be something that didn't, that was below it. So I would pick these for options. Gray limestone, I don't see it. Black shale, yep, that's an option. That must be older because it got cut. So it must have been there first. See if my pen will work here. Which layer is the youngest? Now this makes everything more simple. We knew right off the bat it had to be one of these three, but since I matched up all my rocks, red conglomerate comes out as the youngest. The oldest would have been the gray limestone. Volcanic ash is a good geologic time marker. Time marker, volcanic ash, meteorite deposit, index fossil. In a sedimentary rock bed, index fossils are short-lived and widespread. Rapidly over a large area. Short-lived, rapid, large area, widespread. Those are different ways of saying the same thing. Volcanic ash layer, which one would you pick? Widespread, short time. Wanted to basically just show you one type of cross-section of the Grand Canyon. They show up quite a bit. This question is actually kind of a throwback for something we already reviewed with agents of erosion. You've got that V-shaped there. It's a running water is what made the Grand Canyon. But, you know, these are the oldest rocks. These rocks are younger and younger and younger as they go up, and you can always correlate across the Grand Canyon there. But don't forget, the Colorado River just eroded all of this rock away, and that's what made the Grand Canyon. All right, people love when they see these cross sections, putting things in order. When did the faulting along XY occur? So basically they're going to try to figure out, was it before or after another event? After the intrusion of rock A, was it after? It couldn't be after A. If the faulting was after A would be cut. Since A is not cut, A must have been younger, so that's not a choice. After the deposition of B, C, and D. B and C did not get cut, so they must have been younger. When did the fault occur? After the formation of E and F? That makes sense. Before the formation of G and H. It couldn't have been before G and H because G and H are cut. So it had to be after E and F is when the fault happened. All right, another correlation, matching some things up. So you've got to try to connect similar rocks. Which surface bedrock is the youngest? This is a tough one to do. The layers have not been overturned. Okay, we don't have any index fossils, which makes it more difficult. But I do see some dolostone here and some dolostone here. And so what they're trying to do is to get you to match up that you see shale, dolostone, sandstone. Dolostone, sandstone. Okay, limestone, shale. They're trying to get you to, and I'm not crazy because they didn't make the layers the same thickness, which in reality sometimes they're not, but it doesn't seem super fair to not make things the same thickness in a high school test. Okay, so now I've got this sandstone here. The sandstone here would match up with the sandstone here. It's better if I use the straight lines, huh? So dolostone, but then on top of the dolostone is the siltstone. That would be the youngest. This was a difficult question, which is why I included it. Usually there's an index fossil that helps you match these things up. But hopefully it makes sense that this limestone is this limestone is this limestone, and it would have been underneath, there'd be limestone down here. So you can correlate, you match them up. This is kind of the classic question of, they're going to give you a ton of information and see if they can kind of get you confused. It's really much more simple. You can kind of ignore most of this. What event is accepted as the mass extinction that occurred, made the dinosaurs go extinct? An asteroid hit. Now there are indications that volcanoes did erupt too at the same time, but the asteroid impact is the main thing that happened off the coast of Mexico there. Putting more things in order, please don't forget. I guess that would be the one thing that I'll probably make another video to come back to. Contact metamorphism. Those little lines show the rock getting cooked. So what inference about D, E, and H is supported in the cross section? D, E, and H. What would you pick? I would go with D. They were originally horizontal, and they must have got tilted because they're not horizontal anymore. Why is there no contact metamorphism indicated between L and F? L and F. L and F. So what do you think? What would you pick? Do you see how there's no contact metamorphism there? So why is there no contact? L must have been before F. Okay, F must have been after L. So what would rock unit F was deposited after L would make sense. It must have been later on because it didn't get cooked. It didn't get metamorphosed. Which rock unit was formed most recently? D, right? Because D's on top. They didn't give you D. They made it a little bit more confusing, so work your way down. E was next, still not a choice. Then F. So it's not asking for the youngest in the thing. It's asking for, out of your four choices, what was most recent. Another correlation thing, matching up stuff. This time we do have an index fossil. So this layer matches up with this layer here. Very hard to draw when they're so close together like that. But this is the same rock. Okay, you've got that shell. So if you do that, you know that this is younger than that, and this matches up with this. So that would be my youngest. And then my oldest, if I match these things up like that, would be this. Okay, so the oldest layer is going to be that siltstone in 2. Now, it's hard to separate these things, but remember, you could look that up in your reference table to figure out which symbol is which. I'll be having a whole separate video, something for you to look forward to in a few days on that. Unconformities, so those buried erosional surfaces. That wavy line, the fault is older than. What is the fault older than? Fault is older than anything it didn't cut. So this shale, this limestone, it's not older than the unconformity. It's got to be younger because the unconformity got cut. So it's older than, is limestone a choice? No, shale is a choice. And then I finished up with this one. This is a tough one just because it's a real picture. And I'm honestly not crazy about real pictures, especially in a black and white test. It's tough to know what you're looking at, especially if you're a student and you haven't seen these things. So this is called the parent rock, okay? This is the original rock, okay? This is the oldest rock. This is the rock that was here. And then some different intrusions came through. So this intrusion and this intrusion, A and B both came through, but which one was the most recent? So this is the initial, this is cut by everything, okay? So that's rock C. C is going to be the youngest, so we're down to two, or the oldest, I'm sorry. We're down to two choices. C is the oldest. Which one came next? Well, A and B, but you see how B goes through A? Since B goes through A, B is the youngest, so I would pick choice C. Hopefully that makes sense, putting things in order. There's a lot more with index fossils and geologic time and radioactive decay. Those will all be separate videos. Got a special present for you, Yuri, on your special day, the index fossil video day. Found a little baby picture of you. Check this out. Aren't you adorable little baby? He's only 400 and something million years old, so he probably doesn't remember taking the picture.